Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of exponential integrals. Alright, so if you have an e in your problem, 1e, then you let u equal the exponent. And if the derivative of that u term, the exponent, has the same number of x's as what's multiplied in front of the e term, then you can do u substitution. For example, if we were to look at these problems here, you should be able to see that the derivative of 2x, or x squared, is a 2x. Here I have an x term. I don't care about the coefficients, I just care that I have the same number of x's to the same power. Derivative of a t cubed is t squared. Derivative of square root is 1/2 x to the negative 1/2, which brings it to the bottom. So all these you can do u substitution by letting u equal that exponent right there. All these problems you can let u equal these exponents, and then the du should cancel. Alright? If you're not familiar with your u sub, go back and practice. This last one, even at first glance, when you might say, wait, there's two terms, there's no way that's going to happen. But here the derivative is 2x plus 2, and you can factor out a 2, right? So if you were to, just real quick, I know this is not the actual example video, but if you were to let u equal x squared plus 2x, right, du then would equal 2x plus 2, and right there you should see a 2 factor that you can pull out in front. Okay, so you can make it du equals 2, right? So that would eventually cancel out. So keep an eye out for those things, and that's what you do if you have 1e. Alright? What happens if I take the derivative of the exponent and I don't get what is in front, and I have 1e? Well, in that scenario, what do? Well, you try integration by parts. Okay? So if you cannot do u substitution and you have 1e, then you have to do integration by parts and use the acronym ILATE. Okay? If you don't remember integration by parts, go back and review. But ILATE, inverse trig, log, algebra, trig, and then least favorite for you is exponential. Alright, so when you're doing your integration by parts, you set up your little table, right? U equals and dv equals. This ILATE is a preference for u, and e is its least favorite, so odds are the e to the whatever is going to be your dv term. Alright, so let's look at a few examples of those. So here the derivative of 2x is not an x term, it's 2. So you're going to have to do integration by parts. And in this case your dv would be your e to the 2x, and your u would be x. Okay? If you're not familiar with integration by parts, go back and practice. Same thing here. In these scenarios, either way you slice it, you can't take the derivative of the exponent here and get that. Alright? So what you got to do is integration by parts. Now keep in mind that there are shortcuts that you should remember how to do in integration by parts. It'll save you a lot of time, like the tabular method, for instance. Alright, so if you remember that if your term eventually drives down to 0, like both of these do, right? So if the x is going to be your u, or the x squared, eventually they'll drive to 0. Use the tabular method. Okay, it'll save you a lot of time. So what happens if you have more than one e present? Well, in that scenario, if you have two e's, you let u equal the more complicated expression. Alright, so if we look at these two examples, more than one e, you let u equal the more complex of the two expressions. So in this case, you would let u equal e to the x plus 1, and the derivative would be an e to the x term. So they would cancel. Same thing here, you would let u equal e to the 2x plus 3. You don't care about the fact that it's on the bottom. You don't care about the cubed at all. All you care about is the e term. Du then would be another e term to cancel out. Okay? So again, 1e, let u equal the exponent. If you can take the derivative and get the thing in front, it's going to be derivative of that is the next term to the first power, so it's going to be u sub. But if you can't do that derivative in front, and the derivative of x is 1, here we have an x, so that's integration by parts. Alright, I hope I've clarified things enough for you to practice some of these problems. You'll see that once you do a few of them, they're not as bad as they seem. Practice is the key to learning any of these classes, no matter how hard you think they are. Thank you and have a nice day.